So this is a Hisense TV, model number 55K20DG. So we can see here there's still some, the picture is actually still there. There's only the backlight, so the LEDs behind the screen that are not working anymore. So let's open this up. So now it could be the LEDs which are in here, or it could be the LED driver which is on this board. I'm pretty sure it's the LEDs. Flip these up, then you'll be able to pull out these two flat cables. Remove the connector, pull the whole assembly up here. There's the main board here. Just remove this one too. So to remove the front bezel, we will have to turn the TV around to flip the TV over, and then there are these little clips here. There we have it. So what we want here is to make sure that these PCBs are free to move. The other side as well. And then we can lift up the glass, and when you work alone, I think the best thing would be to lift it up from the other side. Now we unscrew this plastic frame here. A couple of screws and clips as well. So these are 4 individual parts. Now lift up these sheets. There are 1, 2, 3, and put them somewhere else. And here we have our LEDs. Next thing is we remove these little spacers here, plastic spacers. And the best way is to slightly lift them, just slightly, and then push them that way. So in total there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 strips, and with each 1, 2, 3, 4, 5, 6, 7 LEDs, with many of them, if not all, in series. Yeah, looks like they're all in series. Never mind the tape, they're not going to come off by themselves, it's impossible. So these are all the same strips. So it's svh550aa2 times 11. So we could buy these strips, not that expensive, or we could just replace single LEDs. I will try to repair just single LEDs, and after that we lower the LED current, so it's gonna be okay. So first we have to find out which LED is defective, and for that here on the strip is marked plus minus, so we could just apply voltage from plus to minus, and we start with low voltage, let's say 3 volts, because we don't know how many of them are. There could be LEDs that are shorted. They fail either open circuit or shorted. So we start with 3 volts and we increase the voltage to let's say 20 volts, and if they're okay all the LEDs should be lit. Let's test a single LED with, let's say, 2.7 volts. So this is it. It's 3 volt LEDs. Just gonna scratch here the solder mask a little bit. So I'm now at 19 volts and all the LEDs are lit. There's just this one where the little lens came off, so I have to glue it back on. So this strip is okay. So we do the same thing for all the other strips. So we have 5 lit and 2 are defective. They are shorted. That's why I have 14 volts here and they're already lit. So we mark them and then we do this for all the rest. So once we determined which LED strips have defective LEDs on them, we remove the LED strip. Just pull the little latch open here, pull it upwards and then push the connector this way. Oops. This way, so it comes off. Removing these strips is pretty easy. You just have to pull them up a little bit here and then we can slide them out. There it is. Now we need to break off this little lens, this diffuser here. Comes off pretty easy, like this. And this is our LED. And what I usually do is, first of all, I try to remove this little white plastic thingy here. They're not really necessary, you won't see a difference if you don't put them back. But so now I'm gonna heat. I don't like using a heat gun. What I use is a hot plate. We heat the whole part here and then the LED will come off pretty easy. I'll show you. So this is the hot plate and I'm gonna wait until this heats up to about 250-260 degrees. So we pass this over here and it's not gonna be long. This LED will come off. Now this is an LED where the larger pad is the anode. This package is about 2.8 millimeters wide and 3.5 long, and these are 3 volt LEDs. So I got these here from AliExpress or from eBay, can't remember. And these are also LEDs where the large pad is the anode. Looks like this. Not exactly the same pads, but it's gonna fit. So here I will deposit a very small amount of solder paste. Then the LED. And then we heat the LED and the PCB on our hot plate, and it shouldn't take long. And the solder paste will melt. And this is it. Now we do the same thing for all the others. Now before we glue the lenses back on the LEDs, it's a good thing to test all of the LED strips again, just to be sure. And I'm doing this with 19 volts here. Now we glue the lens back on, and if we didn't, hopefully we didn't heat the PCB too much, so these little spots here, these black dots, they're still intact. This was the original glue, and they will fit right in there. So we just put some new glue, a little drop of glue inside here, and then this one on top, and that's it. In some cases you won't be able to put them back into these black dots, because they melted too much, and then this little pin here, it doesn't fit inside. So what I do, I just glue them like this. Just have to adjust the lens so the middle is right on top of the LED, and that's it. Now once this is done, the lenses are back on the LEDs. I will test them again, and I will also check at the same moment if they are really in the right position, just by looking on top of them, because the glue is still it's not hardened, so it's the right moment to adjust anything if necessary. Now don't forget to plug in all these little connectors. Now it's important that the glass lies within the frame here and not on top of it, or otherwise when you put the front bezel back on you're gonna break the glass. And we have to make sure that the PCB is also in the right place. Both PCBs. Perfect. So the 7 long screws go on this edge here where the Hisense logo is, and the shorter screws go on the other 3 edges. Now flip over the TV and then reassemble all the boards and the speakers except the power supply board. Same thing over here. No, you feel it that it's not really inserted, not properly inserted. Yes. Now what should be done is to prevent this from happening again, we should lower the LED current. And the LED current is supplied by this board here. Now it looks like our LED driver is this guy here. It says SELC2010M. The LED current goes through these LEDs, of course, then through one MOSFET and through a resistor to ground. And this voltage drop over the resistor is measured at pin 16, and if I follow this on this board here, then from this chip here, pin 16 measures the voltage drop over these resistors here on the other side, and the current goes through this MOSFET. And this would be these resistors here. There are 2 in parallel, looks like 5.6 ohm. And if we increase this resistance, actually the LED current should drop. And if we go a little bit further down, it actually says here dimming control is done by setting this resistor. So we're gonna increase this resistor. Now here from the previous slide, there was R1 and R2. R2 is 20 kilo ohms and R1 is 62 kilo ohm. Our LED, we have seen there's 2 times 5.6 ohms, so that's 2.8 ohms. And if we calculate the LED current with this, it's gonna be 435 milliamps. And then if you have a look on the board, this is almost exactly what it says on the board. It says 400 milliamps here for the LED backlight, and we will decrease this to below 300 milliamps. And the easiest way to get even lower, but we have to see if it's bright enough, is we cut one of these resistors. So instead of 2.8 ohms we will have 5.6 ohms, and this is gonna give us 217 milliamps peak current. So even if you adjust in the menu, if somebody tries to adjust it too high, too bright, it's still gonna be limited. So the LEDs will be protected. So we do a little surgery here. and we're gonna measure the LED output current to see if this is really if it was really lowered to 220 milliamps. So from what I can see here, we have about 20 millivolts difference. So the maximum current here is what corresponds to 20 millivolts, and that is 200 milliamps. And we have seen also that the backlight came on. So the LEDs actually should be much more protected now than they were before. And of course the old LEDs, which I didn't replace, they still suffered, but with the lower current they should be okay. And if you replace the whole strips, of course, then this TV probably is gonna last forever. Well, thanks for watching, guys. Good luck with your repair, and see you soon.